And let's firstly remember that specific heat capacity is the energy required to raise 1 kilogram of a substance by 1 degree Celsius. Now, if we're dealing with a solid substance like a metal, this is the setup we're going to use. We'll have a metal block with a thermometer inside it connected up to a power supply, connected up to a voltmeter, ammeter, or if you want to eliminate having those two, you could have a joule meter instead. And of course, there'll be a heater inside the metal powered by the power pack, which will heat up the metal. And to limit the amount of heat which escapes through dissipation, we're going to have insulation around the metal block as well. And if your substance is a liquid, you're going to have a pretty similar setup, but this time you're going to have a beaker full of the water and you're going to have an immersion heater inside it. And again, you're going to want to have as much insulation around it as possible to, again, avoid heat loss through dissipation, and maybe an insulated cover on top as well. And for both experiments, you might want to have a balance so that you can measure the mass of the metal or the substance, whatever it may be. And once your equipment is set up, you're going to want to start off by measuring the initial temperature of your substance, and make sure you read the thermometer at eye level so that you avoid parallax error. You'll note this down in the table, and then you'll start the power pack to start heating up the substance. And at regular intervals, let's say 1 minute for your exam, every 1 minute, you're going to take readings of the ammeter, the voltmeter, or joule meter if you've got that instead, and your thermometer. We'll do this for 10 minutes at regular 1 minute intervals, take down our readings into a table, then we'll switch off the power pack, switch off the ammeter and voltmeter, and allow everything to cool down. And once you've done this, you can use the equation E equals mc delta T, or energy equals mass times specific heat capacity times change in temperature, and calculate the specific heat capacity by rearranging for C. Remember, delta T, change in temperature, is just the final temperature minus the initial temperature. And of course, you get this equation in the exam, so don't worry about memorizing it. Now, if you had an ammeter and a voltmeter, and you took down readings every minute for those 10 minutes, you're going to take the average of all of those readings and calculate the average current and the average voltage supplied throughout the experiment. Then you're going to use those values to calculate the energy supplied, the thermal energy supplied to the block or the substance over that time using the equation E equals IVT, which is just a combination of E equals QV and Q equals IT. If you had a joule meter, the joule meter is the energy supplied, the thermal energy supplied to the substance, so you do not need to do that step. Having a joule meter also helps to avoid random errors from readings from the voltmeter and ammeter, so that's helpful. Another source of random errors is dissipation of thermal energy, and that can happen from the substance to the surroundings or from the substance to the thermometer. And to avoid those or minimize them as much as possible, we insulate the substance as much as we can. Also, remember that mass is measured in kilograms, so if you're converting between grams and kilograms, you need to divide by 1,000. Don't forget that when it comes up tomorrow.